Everybody, I'm Annie Sullivan. I lead the speed metrics team on Chrome web platform at Google. We develop the core web vitals metrics and web performance APIs to help people monitor their websites. Michael and I love to talk, and we're here in person. So if you just feel like interrupting and asking questions or whatever, that is fine. I've got like a short intro, and Michael has a demo where he really like to get more hands-on. Okay. So we are working on a new metric called interaction to next paint. It's essentially it's complete, and we're really thinking very strongly about replacing one of the core vitals for simple delay with interaction to next paint. So we want to talk about why are we doing that. So let's back up and talk about what are the core vitals metrics. There's three key metrics that we put in all of our performance and developer tooling at Google for the web. The first one is largest content per page. It measures how quickly a web page loads. Cumulative layout shift measures all those annoying shifts around as you're trying to interact with the web page or as it's just sitting there. And first input delay is the one we want to talk about a bit more. It's meant to measure how responsive a website is to user input. But it has two really important gaps that we'd like to address. First, as it says in the name, it only measures the very first input on a web page, and almost all page loads have more than one if they have an input. Second, it's only measured until the browser starts processing the very first input. It's just a measure of main thread busyness. And there's a couple of problems with these gaps. First, over 90% of the user's time is spent after the page load. And we, as a web performance industry, hardly measure the performance after that at all. And as we've seen a bit, there's some big problems there. So first input delay, as we said, it measures the time that the main thread was busy and it couldn't get to your first interaction. And after we made it a core web vital, we did see a huge improvement. This is all 8 million or so origins in the Chrome UX user experience report. It goes from about 80% pass rate to about 95% are now doing good on this metric. That's because people have been delaying loading scripts that cause busyness at the beginning of the page until after the first user interaction. They've been using APIs like request idle callback, especially via frameworks, to interrupt busy work as the user interacts. But unfortunately, when we look at the full interaction time for all the interactions on the page, we see a really different story. 1 in 100 page loads in Chrome, both on mobile and on desktop, have a complete freeze during user input for over 2 full seconds, just completely frozen. So we think that despite all of this great work on first input delay, we need to kind of expand what we're measuring so that we can tackle the rest of the problem. And what is this freeze like? So you can imagine you're trying to click on a menu, it doesn't open, so you click it again, but it turns out it was code running, so it was just really slow. You clicked on it, and then it started to open, and you clicked and it closes again. That's really, really frustrating. And when that happens, you kind of click over and over again to try and get something. It's called a rage click. And we started to measure rage clicks in Chrome. A lot of run providers actually measure these. This isn't a metric that we made up. But on pages that have good IMP, we see about 2.9% of them also have a rage click. And if you look at poor IMP, we're seeing closer to 9%. So we definitely see a lot of user frustration coming out with these very slow responses. So before we talk, Michael's going to go into a lot of detail about understanding and optimizing IMP. But first, how do we measure this? So it measures user interactions. That can be a tap on a touch screen, a click on a mouse, or a key press on a keyboard. And IMP, this is important. It just measures until the very first update to the screen, which could be a scan. So we're not necessarily, we're not measuring all asynchronous tasks. We're just measuring how long the main thread is just completely blocked after you tap the screen until we can show some kind of update on the screen. And just that is 2 seconds, 100 page loads. So from a more technical point of view, this is what first input delay is measuring. We have some task that's already running on the main thread. JavaScript only has the one main thread. That's why performance people are always yammering on about the main thread. If something is running, we have to wait until it stops. So this is like the delay portion that's measured in first input delay. So you click the screen, something else is running. Now we can handle the event. But there can be multiple event handlers. And for each event handler, right, there can actually be multiple different scripts that run the event handlers. Those all run in serial. And then we've kind of excluded the fact that there's also like micro tasks, like promises get resolved, the first request animation frame, a bunch of other JavaScript can happen in here. And if you did any damage, like you changed the screen, the DOM at all, you've got to run through render and paint on the renderer. And we've drawn this all in a neat little line, but actually, like if you have layout thrashing, like these things can go back and forth over and over again. So say you update the DOM and then you say like, well, like you query it to how big is it, and then you update the DOM again, like in a loop. You can just kind of like ping back and forth for a really long time. And eventually, everything goes to the compositor thread, and we create a frame and we present it. So all of this is what IMP measures. And that's all I've got for like the high level about what IMP is. Michael can come and begin, or unless people have questions that they want to ask first. Questions?
Oh yeah, so there's so right at FI data and MP, like we're looking at then like multiple possible interactions.
Yeah.
Yeah, I mean I have a lot of questions about what that's gonna look like, but I guess
Yeah, you essentially take the highest on the page load. If there's like if you're typing and there's like over 50, then we like go to the next highest, and then there's 50 more, we go to the next highest. So it's like a high percentile interaction, but for most page loads, it's the worst interaction.
So as part of measuring responsiveness on the web, we do a lot of tracing. We look at a lot of real sites. A lot of us at Google live in vanilla JS or internal frameworks or all that kind of stuff. And so there's a lot of patterns that we recommend, a lot of patterns that we pick up ourselves. In particular, on the Chrome team, on web platform team, you know, bleeding edge, like what the web platform's capable of. There's a lot of bias towards vanilla JS. But a lot of sites are built on top of frameworks, and a lot of framework patterns are specific to frameworks. So we've been spending a lot of time trying to just figure out what is happening under the hood. A lot of frameworks are going through a lot of churn right now. I don't know if anybody reads Twitter, but it's very exciting times. So I thought I'd take a stab at, like, if I was to start from scratch, no holds barred, I didn't work at a company that dictated the framework I used. I could just use all of the latest and greatest features. What would I go through? What would I run through? So that's it. I don't know if anybody else has been playing with bleeding edge features, but that's where I've been trying to settle on. It's like, what would happen if I tried to follow some simple patterns, and what effects would that have on responsiveness? What would I change to get the most performance juice out of my framework? So I thought we'd go through a little demo. That's it. So maybe first of all, show of hands, who has even heard of Core Web Vitals? Core Web Vitals. Web Vitals. That's a lot of hands. And he's got a hand up. All right. And of those, who's heard of Interactions Next Paint? Fewer, but still a few. Good. That means we can all learn today, and hopefully. And who's used React? Everyone's used React, even better. Okay, so you could teach me, because I don't write as much React maybe as you folks do. But I've been trying to use, React 18 and drink from the fire hose, take the Kool-Aid, all the latest and greatest features. So I like sailing. I don't know if you could tell, this is like little anchor shirt with like little things. Any other sailors in the room? Nobody's been on a boat before? Nobody. Yeah, you've been on a boat. Okay, good enough.
we are only surfing.
Surfing the web? Oh, I know. Sergey. Terry just winced. All right, so this is our version 0. I want to make a website that will have a little search bar, and I can type into it, and I'm going to get autocomplete results down below. Nothing fancy, few components. We're going to go through one of those simple iterations where we're going to provide autocomplete results. We'll see what the effects are on responsiveness. So right now, it's not actually working. I have a boat. I'm lucky. know, it's my sailboat. We got like a boat last year and we got the whole family thing. So it's a CMC 38. But I don't know if you could tell, it's not actually like search isn't doing anything right now. I could type, some components show up, but it's not doing it. So we're going to implement that together. Before we do, I like spent a little bit of time setting up the components here, the UI, I added some tailwind and whatever. So what's my baseline? Like, how's it doing right now? I imagine folks have used the performance panel to do traces and to uncover things. So I could do that. I could go into the performance panel. I can hit record. I can try to interact with the site. But that takes time. Like, you know, you got to hit that record button. You got to make the recording. It takes time to process it, and you got to read it all. And you might find that nothing happened. Like, that was not an interesting recording. You don't even know what you're looking for yet. So I like to do things a little bit more real time first, like get a sense for something, find a problem that I could reproduce regularly, and then I reach for record, so I know exactly what I'm looking for. So luckily, the core Web Vitals are implementable in JavaScript. Like, we work with the Web Performance APIs in browsers to ship to JavaScript the like raw underlying signals that you could build core Web Vitals out of. So this interaction to next paint is this upcoming, you know, Web Vital, and it's really useful for responsiveness. Bump that font a little bit. But you can actually just implement it in JavaScript, like on any page. Even if you don't own the page, you could just open DevTools, drop a little snippet in your console, add the little JavaScript to the thing. And so, like, as I interact with this site, you know, I just clicked a few times and I type a few times, and I'm getting like a real-time log that comes from the page itself. It's not a feature that the browser has built into tooling or anything like that. I'm just using JavaScript. Does that make sense? So I like to do that. I'll visit random websites and I'll literally open up console, paste in some JavaScript, and then I'm seeing a live view, like a real-time view of performance. I could do this for CLS, I could do this for LCP, but interactions in particular, very useful. So I'm seeing the time it takes end to end to literally see the pixels update of this interaction. And it's down to 24 milliseconds, 16 milliseconds. I'm on a pretty beefy desktop. It's as good as it gets. You know, folks know how like screens refresh at a certain refresh rate, 16 milliseconds of latency. That's as good as it gets. All right. So pretty good baseline. I got no issues with this website. I don't need to go to trace it. So far, so good. All right, let's look at the code. Search is not working. So I have a component. This is what runs like the whole shell of my UI. I'm fetching some data, in this case, a big blob of JSON. I do this once on startup and I sort of catch it locally. Keep that in. We can talk about this later. I'm using a sort of modern React pattern, but there's a bunch of different ways to do this. I got a little bit of state. It's just the search term that I'm currently running. And every time I type into that search bar, I just update the search term. And then my autocomplete results are based on that. Okay, it's a pretty simple setup. We'll go. So search isn't working. I got my search bar here. It's not doing that much. And that's because I'm always showing all results. So let me replace this with some work I did earlier. Filter results, and we'll take a look at what that does. So here's my filter results function. So it's going to get all my sale data. It's just a big blob of JSON that I already fetched on this page. It's going to get a search term, and it's going to just loop through the list. It's going to say for every boat, every item in my JSON big blob of array, I'm going to try to score it or match it. So I'm going to take this string that I'm searching for, try to do a fuzzy match using a library that I found online. It's a really good library. It's really good at matching strings. Every single one of those results gets a score. We're going to sort by score and take the top 10 or something like that to show it in our results. But it's a loop that does some work that we're going to show the results. All right. And I'm calling that function directly from my component. So I get my results, I sort of slice them, and then I just show the top 10 results. I think it's a pretty common pattern that's out there. Let's try it out. Okay, hot module reload and work. So now, started typing. I don't see anything. Right? It's taken a while, but it's not just taking a while to show me the search box updates. It's not just showing. I literally couldn't even see the keys appear in the search box. All right. And the console logs are glowing red. That's how long it took me to see those pixels. So when we say interaction to next paint measures how long it takes, it's literally any visual feedback whatsoever. Okay. So as a developer, I wrote a component, it called some JavaScript, it filtered some stuff. Felt like a natural way to implement this. But it's completely blocking. It's literally in the main thread, in the main loop, like it's in the hot path to get pixels up there. Does that make sense? How are we going to fix it? All right, your first choice is grab an algorithms textbook, go to that filter results function and try to run a fuzzy searcher that's like more efficient, right? Like, I don't want to do that. I'm not going to start there. It's a library that I trust is pretty good. It's as good as it gets. So I have to run that code. That's the code I'm going to run. For today, that's like, we're not going to get into algorithms. It's all right with you folks, unless somebody's got an idea. So let's just try to like move that ticking time bomb, like that code that's going to take a long time. Let's try to shuffle it around to get some, do better.
We have like 100 milliseconds, right?
We typically advise 100 milliseconds for any interaction to show any response, even if it's just to acknowledge that input arrived. Right? You don't have to fully respond or anything like that. There's different research about how long I think, but like you should know something's happened. For INP, our threshold is actually 200, not 100. But the reason it's 200 is because it's measuring every single interaction. And we're not saying the average needs to be 200. We're saying nothing should be above 200, all of them. So your outlier, like your worst case, shouldn't be 200. And to hit that reliably, you really probably want to be under 100 for most. Does anybody use React enough to, yeah?
Go
ahead.
The question was, in mobile, I know there's like a delay touch input. Is that including that?
It is absolutely including that. Yeah. So they're old fashioned. Who knows about the tap delay? Explain it to us.
300 milliseconds.
300 mils. Where's it come from?
It gives the time for the browser to allow for a user to double tap to zoom the website.
Yes.
So browser needs to wait to see whether the user tapped the second time.
Yeah. Yeah. It's even more dubious than that. You're absolutely right. Those were the origins. When Apple shipped the first mobile Safari for the first iPhone, there were a lot of not optimized mobile pages with a lot of desktop sites. And so little tiny squares had to appear on the screen. So they added support. You could double tap on any text or anything, and it will magically zoom to the right viewport size. Useful feature. But they also kind of added, for the first time ever, like first-class support for touch to the web. And if you register touch listeners, you can actually override click events. Like you could basically say, I'm handling touch. I don't want the default backwards compatible behavior that they would simulate. And so it has to know, are you going to handle the input? Are you going to prevent the default? Are you going to thing? And so we need a little bit of time for the code to run before we can fall back to the thing. And on today's web, you can provide a very simple hint, like a mobile viewport at the top of the page. You're basically saying, I'm not going to do that. I'm going to use modern pointer events thing. You could still get the double tap to zoom on specific components, but like most of the page, most links, most buttons aren't going to do prevent default. They're not going to do all this stuff. So you could allow it to be fast tap. And so it's a best practice to add a mobile viewport, and you get lots of loud warnings if you don't. Now, if you forget to do that, what actually happens is we won't run your synthetic event handlers until after 300 milliseconds. It's kind of complicated. But that, like you're tanked, like that, it sucks. And every website you've used that forgets to add a mobile viewport feels sluggish. And so, yeah, it's actually, we think it's a good thing to do it next time. Does anybody write enough React code to have an idea about what we could do?
Sure. Again.
Yeah. So 2 components. The outer one, it's just managing an input event, setting some state. It's got the search bar and the autocomplete results. And the autocomplete results are literally just saying, filter based on this search term, take the top 10, and then just show them all. Render a list of components.
don't know about React, but that would be bounce.
Yeah.
Debounce. Very good. All right, we'll get to debounce in 2 seconds. We'll get to debounce in 1 second. But there's a relatively new feature in React, but most frameworks, Solid has this, I think Svelte has this thing. Has anybody heard of transitions? All right, Tom, you're up. Yeah, you shouldn't have nodded.
Oh, I've got a back end. Wait, hang on.
Not view transitions.
So not the one that, that's the second.
Yeah, those are view transitions. You know, in web platform, we have a very, very excellent time with naming 5 different things the same name. So yeah, it happens.
What's a frame?
Yeah, what's the frame? Anybody heard of like use transition hook? Nobody. Okay, great. Today we learned. So usually in React or any of our state-based UI frameworks, if I say my component produces this view based on this state, right? Like your UI is a function of state. When I update that state, our frameworks say, well, state has changed. I have to update the view. That's what you told me to do. That's what I'm going to do. So if I update the search term and my search results are expressed based on the search term, I have to update search results. Like that's just what you're asking the framework to do. The transition is saying, I'd like you to make that change, but you're allowed to do it in the background. Like it's a lower priority update. Don't block everything, updating the state, updating the view based on the state. Go compute it, and when it's done, then update the UI. Okay, I'm basically saying this isn't critically important. You're allowed to do other things in the meantime. Pretty neat feature. And so for responsiveness, what does that mean? When I'm typing into the search box, I really want to see those keys right away. That's not, in my opinion, that's not part of the delayed update. But the search results, that's part of the delayed update, right? So I want to split. I want like, this is important. I need it now. This is fine. Take your time. All right, so let's try to do that. So instead of is pending, I'm going to say use transition. And then this returns is pending. See, this is where you're going to have to forgive me. Transition. All right. Nope. It's hard typing on a pedestal. Right. So first thing I'm going to do is I'm just going to take my search term state and just put it in the transition. Let's see what that's like. Hopefully I didn't make that. All right. It didn't do anything. So it did one little thing. I don't know if folks can see that the screen goes fuzzy. Like the search results go fuzzy. All right, now that's not actually it. So something went wrong. I don't see what I'm typing, but I do see the tab contents change. And some of the durations are actually going great. So what I did there was I said, I don't mind updating the whole search term. I don't mind updating the contents of the text box. I don't mind updating the search box in the background. But I have this thing, this signal is pending. This is React saying, once you start a transition, the current state of the UI, it's pending now because there's like a thing happening in the background. And so I use that to update some CSS to blur sort of these. Okay, so I'm almost there. I've got some like immediate blur that like lets me know something is happening. But let's see, I'm gonna do this.
Are you updating the search term and doing the search algorithm at the same time?
2 different components. And now I'm splitting the state to basically do one there and one there. Exactly right. So I'm going to call it, sure, set auto search term. I'm splitting my state so that my autocomplete will be a different part. Okay. All right. So now I split my state into 2 pieces, the part that's in the search box, the part that's in my autocomplete results. And I can decide when to update each of them. So I'm going to update my search term right away. and I'm going to update my search results in a transition. Let it happen in the background. Okay, this is out of the box. Frameworks provide this across a whole slew of them. And you're giving a clue to your framework that like logically it's okay to split these two updates. So let's see what that feels like. So now, if I'm lucky, when I type a character, I'll see the character result. Okay. Type a character, the thing goes blurry. It's still taking a little while. There's a couple of measurement effects here. We can talk about that. But at least, hopefully, folks agree that if I'm typing nice and slow, one character at a time, it's an improvement. That makes sense? All right. But if I type quickly, it got really bad. Okay. My first character updates the state. I go ahead and set it. I start a transition for the stuff that can happen in the background. Now React is like, okay, we're in the background now. I'm going to start searching through your search results. And it still takes a long time. Like that function we wrote earlier, it's still darn slow. So as soon as I start typing more characters, I'm saying, okay, time for a new result, throwing more work at it. There's no more, like I'm still blocked. That makes sense? So this is where you mentioned debouncing. Debouncing is saying, it's going to take me a while to do this work. I don't want to start on it right away because you might still type. You might type more. Why would I start filtering all your search results if you're going to type 5 more characters? I'm going to wait for you to stop typing, then I'll filter. Okay, it's an old-fashioned technique. I think it's been around for a long time. There's lots of ways to do it. So let's try that, see if that works. So what I'll do is I'll move my start transition out of the handler. I'm going to do something called use debounced effect. Perfect. I'm probably going to type a bit slow, so I'm going to make 1,000. So this use debounced effect isn't built into React. They give you the tools to build this. This is like a custom hook I wrote. But what I'm saying is every time search term changes, wait 100 milliseconds. And then after 100 milliseconds, go start that transition to update the autocomplete.
Who's that 100?
Thousands, right? Yeah. It's like if I was writing vanilla JS, I would set timeout 1,000 this thing, right? I would just set a timeout, and then every new key, clear the old timeout, create a new timeout. New key, clear the old timeout, new timeout. After 1,000 seconds, I'm assuming the user's not typing anymore. Go do the search.
Then I implemented it, debounce effect.
Yes, sir. You want to see? You trust me. It's just a set timeout. There are libraries that do sophisticated things, but this one's like a 5-line, just set timeout.
And the use transition, is that a set timeout of 0? Or?
No, the way that's a built-in that's integrated with their scheduler. A lot of libraries do this. You could think of it as similar to set timeout 0 after request animation time. So you're going to wait for the next rendering and then do something after rendering's done. But it's more complicated. They basically say, if we're busy rendering, we're not going to start this transition. We're going to wait until we're done rendering what is important. Once that's done, then we'll get started on background transitions. And it's even more sophisticated than that because they can kind of discard the work if it's things. So it's a pretty cool feature that's a way to express what you want. And then the framework gets faster, or your app gets faster. All right, let's see if our debounce helped. All right. So with debounce, I might be able to actually type multiple characters. Oh my goodness. That feels a lot better. And then when I stop, then we get started. I didn't get a single long interaction. All right. So I'm going to delete some. Then I'll type 41. Uh-oh. Now I got a long interaction. Let me try that one more time so I can take some time. This updates. Okay, that's all working. Then after some time I get things. Maybe I need a loading spinner. I don't know. We'll see. No loading spinners, I understand. So it's mostly working, except let's see what's another. If I type this and then wait. So you might not feel this as much as I'm feeling it. But now there's this like weird problem where sometimes it's a bit slow and usually it's not. Have you ever had like a website where like sometimes it's slow, you could swear that there's like something going on and then kind of figure out the timing and you work around it. Super irritating. So debounce is wonderful. We have this like super long thing happening. It's janky. It used to happen with every keystroke. That was annoying. We moved it a little bit behind, and now with debounce, we're moving it into the future. We're saying 1 second after I stop typing. So as long as the user types really quickly, as long as they're typing faster than a certain rate, you're going to keep replacing that debounce. And if the user stops and takes their hands off the keyboard, then we'll do the work and then you'll see the results. But like if I type right in the middle there, like the debounce happened, now we're calculating, and now if I type, it still holds, right? Because main thread is still blocking doing work. So we decreased the statistics, like the odds of hitting a jank went down, which is pretty good. But INP actually measures every single interaction. And it's going to say, if you fairly consistently have these types of things happening, we're going to judge you on that worst one. Because that's, as a user, like that's what I remember. That's what I. So this can help, but if you're just moving like slow issues around, you're going to get hit eventually. So the interesting thing about interactions is if you actually improve your sites and improve most interactions, users are going to do more. And if they do more, they're actually going to hit these things more often. So it's like a double hit. So that makes sense? So debounce is a useful technique, but you're just doing your best to take this terrible moment and hide it under the rug. Like, you know, what's the most opportune time to like seize the whole site? Like, it's tough to pick a perfect time. The second problem is, you know, I type and it wasn't janky, but like now I get my results. Like I on purpose delayed all results by a second, and then I get started, which took already a long time. Like it's just slow. It's not. I could see what I'm typing. That's pretty good, I think. So we really just got to make it fast. Like we really just got to make. I said we wouldn't, but we got to make it fast. Okay, so let's go back to the code. So I'm going to get rid of the debounce. Okay, that's not. Success is not down that path. So let's go back to our filter. So there it is. So here's our filter results function. So what's it doing exactly? It's saying for every boat in our big blob of JSON, try to match it and then look at the score or whatever. I don't want to re-implement score match. That's the hard part. That's the fuzzy string match. I got that out of the thing. But I'm actually doing this loop and asking every single boat to sort of try to match itself against the search term. There's like 1,000, 10,000, I don't know, 100,000. I don't know how many boats there are. And I'm going to go through that whole loop before I can show any results. And I'm going to block the main thread for that whole loop. Nothing else can happen. No other inputs can happen. The browser can't do anything. Like it's like you're not allowed to breathe while this is happening. All right. So we want to let the browser have a chance to breathe, even if our UI is going to not show results. Does that make sense? Has anybody seen like a pattern for doing this kind of thing? Shielding. Surrogate. Show up. All right. Has anybody heard of like trying to let the browser yield? We're trying to talk about it more, but
So like kind of like staggering,
what do you mean by stagger?
like staggering, like what you're fetching from the data source.
Yep. That would be very good. The thing is, in this case,
Yeah.
it could be that the last boat is the perfect match.
Yeah.
And I want to show the top 10 results. So it's possible, like you're right. I could actually give you a progress indicator. I could say like the top 10 boats we found so far, here they are. I found a new boat and I kind of like, you know, they filter in.
Yeah.
That would almost give me a sense of progression. And that could be a really cool UI.
Yeah.
But in this case, let's just say I want the 10 results to be the perfect 10. I'm going to wait. It's a good idea. So what I really want to do is right here, I would love to say, let the browser breathe. See, it even tried to autocomplete, so do things. Okay, I want to let the browser breathe. And there's a scheduling primitive coming down the pipe. It's not available yet on any of your stable browsers. It's available in Canary. But it's really easy to polyfill, actually. It's called like scheduler.yield. You literally just say, you have to await it. You say, I want to await scheduler.yield. And what you're doing is saying, Anything else that wants to do some work, I'll give you a moment to go do that, and then I'll resume. All right. So in order to use this feature, I have to make this function async. And since most browsers don't have scheduler.yield yet, I'm going to polyfill it. So it's very easy to polyfill. The easiest polyfill is just to use set timeout 0. You're going to wrap a set timeout 0 with a promise. You're going to wait for that set timeout to return, resolve the promise. Does that make sense? We can take a look at the polyfills in a sec. There's better ways to do it, but like it's trivial to do yourself. So with each turn of the loop, I'm going to say browser, go ahead and work. Turn the loop, browser, go ahead and work. And if there's any new input at any time, we could replace search term and get started on something. All right. So this thing used to block. I didn't actually do a performance trace, but it took about a second. I think that's how it felt like to me. We just blocked for a second. And now we're going to chunk. Any input at any time, immediately replace the old results, get started on the chunk. Fingers crossed. Okay, so this is now an async function. It's like painful to use async functions from most frameworks. Okay, except all of them are going through a transformation right now that is actually making it easier to do. Has anybody caught wind of any of that? It used to be difficult, but it's pretty darn easy now. So my autocomplete, it's calling filter results. So for React, I'm going to use a promise. If anybody's heard of the use hook, there's a lot of people are talking about it. That's it. I told React I want to use the result of this promise. React is going to be smart enough to say, oh, that's a promise. It's not ready yet. I'm going to stop rendering this component, wait for it to resolve. Once it's resolved, I'll resume rendering and we'll just it's like saying await the result, but it's in React parlance or whatever. Still feels synchronous. It still feels like component code. That was it. One little hook. Pretty sweet. So now I'm calling an asynchronous filter results that is yielding regularly. Everything else about my app is the same. If I didn't forget anything, let's try it. All right. So I will refresh just in case. I'll click here. I'll type C and C. I saw the text. Still takes a while. The results show up. 38 dash. I'm going to try to put a fast one on it. I'm going to try to sneakily, I'm trying to time it. And at the moment, it looks like every single one of my interactions was nearly instantaneous. You could see things going fuzzy. You could see, I spelled that wrong. Like there will, if I got it right, there will never be a moment where I'll have a janky result such that I won't see my text. That's all I did. I just added yield points. Browsers never blocked. If we were doing performance traces, you would have seen a big block of time, a big long task would have been total blocking time. And now you see little chunks. We're playing nice. All right. It's one problem. We can make one more improvement. So I forget if I left it in. Okay, cool. I left one feature in here. So anybody use performance.measure before? Come on, Terry. What does performance.measure do?
Oh god.
Yeah.
Hopefully, does it have something to do with line 24? Is it a reason that start value? Yes, we're here. Okay, so on line 24, we have a start, so it just kind of gets the time in milliseconds, like relative to the application or something like that, or maybe you can extend it.
Yep.
And then on line 35, we're saying like stop. It's like a timer. We're saying stop the timer, and this is now available performance tab, or you can now get that.
Absolutely. Yeah, you're adding a duration from start to end. It uses the current time as the end when I call performance.measure. And you're right, I started time right here before I did this loop. And I want to know how long does that loop take. And the reason I added performance measure, I could have console logged. I could have said this takes 2 seconds. But if I use performance measure, I'm adding that little thing to the performance timeline. Later, I can get them out. I can still console log them, but I can do this. If I do go into my performance tab and I do start a recording, like when I'm going to refresh, start, clear the caches. And I type CNC. And we'll wait for the results, and then I will stop tracing. Beauty. See, this is why I like those console logs and I don't like recording every single time because it takes 5 seconds at least. And when you're demoing, it takes twice as long. All right. So, okay, I have to make this a little bit smaller because I can't read. So you get these beautiful, I think they're beautiful. You get these timings on your timeline. You can actually see, I just added a string. So I'm saying I finished computing filter results for the letter C, right? And then I got started computing filter results for C and that's the manufacturer of my book. Computed filter results for C and C. So each of those is taking 6 seconds. I got started computing C and before I was done computing C. I got started computing C and C before I was done computing the last two. So I'm computing 3 different search results in parallel. Because that's what I asked. I wrote, I said, all of you be nice, be friendly, share. Every new search term, start a new search filter. Be nice, share. If I type fast enough, I'm going to ask it for 5 queries, 6 queries, 20 queries all at once. And then that first one, it's never even going to show up on the screen because I've already changed the term. So I'm going to like be busy computing all of the results and I'm going to throw them all away. All right, not good. No bueno, no bueno. So it's responsive, but it was irresponsible of you. Okay, I just coined that right now. While we're here, I will show there's this interactions lane, which is relatively new. I probably should have demoed it back when we were having terribly slow interactions, but you can actually see if I like zoom in, you'll see these were our interactions. There was a pointer down, pointer up, there was a click. And most of the time, the main thread was idle. I'm kind of visualizing everything. You have these like tiny little tasks doing little itty bitty pieces of work because I'm yielding like super aggressively, probably over yielding in this case. Like we could talk about how to improve that to yield less often. If I wasn't doing that, you would have seen these filter results just like log. How are we doing for time? Wrap it up? Okay, I'm gonna wrap it up.
No, maybe not.
All right. So
That's
for,
everybody else. I'm the organizer.
for my last magic trick, all I want to do is when I know I'm going to start a new search result, I want to just abort the previous one, get rid of it. And that way I'll have more time, more slice of the main thread for myself. That makes sense? I don't want to run multiple parallel searches at once. So this one's a little bit more complicated. I told you about this amazing feature called transitions. When you start a transition, you're doing it in the background, could replace all those things. There's no way to clean up after a transition. Transitions are smart enough to say, when you have a new search term and you start a new transition, I'm going to get rid of the old one, but there's no way to clean up after them, not yet. So this is a feature that I'd love to see added to a bunch of frameworks.
I just, I'm a little foggy on this, but can't we use generator functions here to get a little more control over our asynchronous activity?
That is effectively what I am doing. How would you use a generator function?
I think there's a couple of libraries. Well, I mean, you're doing it where you can kind of do your yield and call, but
Yep.
cancel a little easier.
Yep.
I bet this is foggy for me.
Yeah, absolutely. So that is what we want to do. We want to cancel that word. So we could use a generator. There's a bunch of different ways that we can change our filter function to support cancellation. With a generator, you could just stop asking for more results, for example. Okay. The problem here is, what's the signal? When do we cancel? Right? So with each new input, I want to say, cancel the previous transition. And there's no vocabulary in React to do that. Once the transition started, it's on its like own little world. The component is doing its render. It's unaware of this thing. You don't even have a handle to it. Okay. That's the part we'll build. And then I'll show you how I solve the cancellation problem. All right. So I'm going to wrap it up a little bit faster. I'm going to cheat. And we did all these things already. We did all these things. I did it with, I memorized it. All right. I am going to use a special transition hook. So I called it an abort signaling transition. It's just a custom hook. It's not that bad. And I'm going to call it here. So instead of calling a regular transition, I want it to automatically signal an abort controller. Abort controller is just like a web primitive. It's a vanilla JS feature to basically say, I want you to cancel some work. You can use it with fetch API, whatever. So since I like using it with vanilla JS, that's the way I went. And now with this like minor tweak to this hook, this transition will automatically signal. Every time the transition gets canceled, your code can hook onto it and just cancel itself. It's just like a cleanup function. So I'm going to, let's see, abort signal equals abort signal. That's all good. Search bar doesn't need one. Autocomplete needs the, let's see. I gotta shuffle some things around. Of 2 keyboards. All right, that's good. And pass that into this. Nope, not that one, this one. Yep. All right, all right. All right, I think I got the skeleton. So this is what you get. After you yield, you get to ask the question, was my abort signal aborted? Okay, and that signal comes from my main component that's already in the middle of a transition. Any new transition signals the previous one. And I love that this happens automatically. All your code can basically get a signal and then automatically decide to clean up. It will also work well with a lot of the task scheduling APIs. A lot of the task scheduling APIs, fetch, all of these things, they all base on, like they work with abort signals. And so in a bunch of React code that's already happening, cancel fetches to the network, all this stuff. In this case, I'm going to type another performance measure. This time I'm going to just show that we're aborting results to thing. And let's see if it all works. Okay, fingers crossed, because that was a lot. So CNC. All right, I saw some results. It felt a bit faster. Again, going to the console, it's not that responsiveness is faster. It was already fast before with the auto yielding. I could see the keyboard events and all this other stuff. But the overall end-to-end latency for me as a user was still good. So this is also this -38-3. That's my boat. I have a sailboat. All right, stop. Then final demo. Look at that. No more staggers. All right. Now, if I zoom in, I started, but I aborted. I started, but I aborted, etc., etc. Looks like I was typing every 200 or something milliseconds. That's just how fast my fingers move. And then finally, this is the one I settled on. I didn't replace this one. This is so much better than debouncing, because instead of waiting, doing nothing, I'm getting started eagerly. And then I cancel the previous one once I know there is a new search. And if there doesn't happen to be one, I actually get faster results overall. Okay, it'll never be this bad timing of a debounce, and it's faster overall. Now, some improvements I could have made. Maybe I'm yielding too much here, but that's it for the main demo. You have one more thing, but why don't we pause for questions? Y'all seem to follow along. It makes me feel good. I got a bright audience.
We somehow use web workers for it.
You could use web workers. I would have had to move the work all over to the worker and then take the results from the worker and then inject them. So I would say that's the old-fashioned way of doing, not the web workers part, but like this idea of I'm going to start some work with like a state update or an effect in React parlance, whatever. And then when that effect is done and I have my results, then I'll update state. So when I change my search, I'm not really changing my search results or redoing my tree or something like that. I'm just kind of kicking off some background work. You could also just fetch and do it in a server and ask the server to do it. But I wanted to start with the challenge of saying, could I do it with transitions? So I think there will be places where you want to do that. And there will be places where really it's just some code you have locally. It's on main thread. It's not that convenient to move it. I just took a few lines to do this kind of stuff. And so for most of the code that is meant to be running on main thread, you could do these types of patterns and just make it not janky. Like it is possible. That was the proof point. Yeah, sure. For looping through a bunch of search results, probably I should have moved it off thread or made it faster. But I think a lot of our code doesn't look like that, right? Like a lot of code is just code that calls code that calls code that calls code. And it's this big tree of stuff. And you just add a few yield points and it all gets faster. Yeah.
This matched up all well. The one was going for the all or nothing down that's fine. And rather than really nice well, but this will face an SEO metric that might adjust some rankings.
Yeah.
What are horrible things by telling them that they can't hack it? So if there was a change like one pixel on the page to try and gain this, work quickly, or is there?
Absolutely. Yeah. Go change one pixel on the page. Yeah. I'd be really happy.
Yeah,
So here's the thing. We're with INP, it can't know whether that paint was useful to the user. It cannot know. But what it can know is that at least the site was not shooting itself in the foot by being completely blocked. So I think you're saying, couldn't I just be nice and responsive with a very not useful piece of feedback? But most sites could not. Most sites could not just be nice and responsive, like even if we challenge them. So if you want to go through the process of fixing your site to make it very responsive, but then you choose not to provide a useful response to the user, because for your business metrics, it doesn't matter. Like I at least go through the process of trying to make it responsive. Why not just show the result? Yeah, that might not be a thing, but I think that the first necessary step before anything else is to try and just make it like responsive, and then we'll go from there. I do think there's going to be lots of situations where that first paint isn't the main result and the user's still waiting for something useful. But the thing is, the browser provides default styles. Click a link, it'll highlight, it'll hover, it'll activate. Click a button, you see it depressed. Checkboxes get checked. Accessibility features, those all fire. So even if you just updated that one pixel, the browser can do a lot more like it thinks. So I think it's mostly not going to be a big deal, I hope.
Yeah, and a couple of the things that 100 milliseconds research, that is about the first step page, not the sailboat results. It's like, can I see this on typing? And then the situation he kept getting into over and over again, where he fixed the first, and then like you type another key. Like we're seeing that when we look at traces from the wild constantly. Like you can maybe hack that first, but the second one is gonna hit whatever work you delayed.
And to be clear, like we want to get them.
Yeah.
What we're looking for is
Yeah, yeah.
Yeah, I think you can, it's pretty easy to construct things like this where you can see why it would work. We have a couple of demos already on GitHub where you can see like, okay, the first input, yeah, you cheated, and the second one, you did the brick fall.
Yeah. The debounce example with the weird timing. Like if you're just moving stuff by wrapping it in set timeout, it's still gonna run, it's still gonna affect the next. So in practice, it's pretty difficult to make a site that's always responsive at any time. So, but there are strategies.
so the win here is because IP is not only measuring first, right?
Yes.
That's why the metric will be better, because it will catch. If you cheated the first one, it will still catch the
Yes.
subsequent delays.
Yeah.
Right. So that's why it's better than FNT.
Yeah, it's better for two big reasons. It measures all interactions, any interaction, whole page life, and it measures like actually the whole, of course, like that first input, but it's measuring the way the browser thinks of the whole pipeline. The thing, like, have folks ever looked at?
So the browser's like literally frozen, right? Until that whole pipeline. So you can't see anything like the style, the change of the button, the key.
This is Chrome's rendering architecture, but like it doesn't matter.
It's part of what I meant.
Yes. It's meant to be complicated, okay? It's meant to be complicated, but like when you say inner HTML equals, and it feels like you finished because that line of code is executed, it doesn't mean that that's what's actually on the screen yet. You have to go through all these stages. And so INP not only measures every interaction, but it measures it all the way to the end of all of these stages. And so if your input delay is the problem because event handlers not running, if your event handlers are the problem, if the rendering is the problem, if anything is a problem, it's all going to get caught. So for both of those reasons, I think as an example, you can have you can have your main thread be instant, but you put a giant image that takes forever to decode. In Chrome, we're going to wait. We're not going to show anything until that image decodes. So just adding a big image in the same frame that you did something else, you think it worked, but it didn't. Like the user's still waiting. CSS is a common problem. Designers add sprinkle like CSS hover effects where you get this nice blur right when you hover over a button, and then you go to click the button and nothing's happening because we're CSSing like this nice blur. And it was a wonderful effect, but it cost your users 2 seconds or whatever it is. You know, go to the Tailwind website and try all of those interactions. They all look really nice, but some of them, yeah. So all of it counts. I think that's a big win for IMP as well.
My understanding is that this is measuring like the worst thing that happened
Generally.
to a user over the entire time that they're on Teams. So is there any guidance about how to, and then like if there are enough of them that ends up being like a P95?
98, yeah, but yeah.
Is there any guidance on using this for like an aggregate metric? So like if we wanted to see like how does this do it across our entire user base? Like,
Yeah.
it seems like the metrics like kind of start to get a little funky.
Yeah.
What's the meaning of
Yeah.
this thing? So is that how this is meant to be used? The guidance?
Sure. So if you want to match the vital, the definition of the vital, then what we're basically saying is we're assessing whether the user experience was positive, right? Like was it a good user experience? And so we've done user studies, and I think that users tend to remember that worst outlier, and it's like a pretty good way to judge the session whether it was thing. So if your goal is to understand how your vitals are scoring and how your users are probably experiencing, then we do like that. But if your goal is to improve your site performance, and you got a bunch of engineers working on a bunch of different features, I think measuring all interactions is very useful, right? And you want to have like a nice little histogram of every single interaction, all of them. And it's true, the final assessment is based on those critical ones, and driving those down is going to move the metric. But if you make 50% improvement to your site overall, it just happened to be on what was already fastest or something, like you still should measure it. So it is useful to do both, like measure every interaction, but then also summarize the whole page experience. That's the way we like to do it. But guidance, I mean, this is fresh off the presses, I think.
Yeah, I mean, like the webvitals.js is a reference implementation, and that's kind of like our guidance on how core web vitals look, particularly role, like to the Chrome user experience report. But the web performance API that underlies it, event timing, very specifically made that very general case. There's a great talk by Noam Elfman, who works at Excel online, where they wanted to know like, okay, but exactly what's being clicked on, so they can group what in Excel was clicked on or what was interacted with, and then split the times by that. They split it before and after they were finished loading, so they can tell how much the loading was contributing. So you can slice and dice the metrics in different ways beyond what we have with webvitals.js.
So I reverted to an older version. Can I show you one more demo, or do I want to go home?
One more.
One last one. Okay, Sergey, for you. A coworker of ours is working on a really awesome feature called long animation frame reporting. Does anybody use long tasks or total blocking time? Jenna has. It basically says anytime JavaScript blocks the main thread for over 50 milliseconds, that's a long task. Like if you're blocking that long, you're at risk. You're at risk of interactions being affected. You're at risk at animations being affected. Like 50 milliseconds to completely block for one task is a lot. But it comes out there are various flaws. Number one, okay, cool. We measured a long task. Why did it happen? Help me out. Like, give me attribution. It's been a common request. And so we've had a coworker who's been spending a lot of time trying to make it a better API to give you more assistance, to give you more insights. The second thing is it comes out, it's like a very awkward definition of tasks. Like, what does it mean? It kind of doesn't meet expectation, doesn't always work. So he's also evolving how it works to make it work better. So both things, it's going to measure just better, more. We can go through the details. And it's going to think. So I'll show you. No, that's not what I wanted to show. There we go. So this was, okay, cool. I already hit one long animation frame. I know it's tiny. I'll make it a bit bigger. That's as big as it gets. Hot off the presses, Chrome Canary. If I ask for all long animation frames that this site had, and this is, I undid some of the recent good work that we did to this thing. So this is back to the janky demo earlier. I hit a case where for 258 milliseconds, the page was completely frozen and available in field data to JavaScript. We might eventually see if this all passes things. It's like, a proposal for those of us grumbling about web standards. And so you'll see things like, when did we want to start rendering? How long did it take? What was the effective blocking time? I'll open up my scripts and it'll say, here's exactly which scripts were running on your page that contributed to this time. And I can open this one up and it'll tell me, here's the line of code from the script name. So it's that third party that you added that hooked onto your event handler that ran something. You'll see it by name, line of code, all this stuff. How much forced style and layout did this thing do? Like maybe right in the middle of your event handlers, it's doing layout thrashing, like I mentioned. It's going to tell you that. But like just the amount of metadata that GNOME has been on a tear to find will be a very, very useful source of data that in aggregate, you'll be able to really get down to those, like, here's your top 10 list. Like these problems are recurring over and over with a bunch of interactions on a bunch of different pages. Fix these 10 things and you're going to have this much of an improvement. That's the goal. The second thing is, so the question, it exposes a bunch of interesting time points together with event timing, which is what we use to get INP, the things that gave those colored sync blocks. You can kind of mesh the two together and paint this picture of like exactly what's happening with our interactions. So this is like super advanced, but early, hot off the press. Again, not what I wanted. All right, so now, if the demo gods be good. All right, so I had some slow interactions. Demo gods not be good. Plus this is super large. All right, I'll have to record it and send it out. I dare not, but this nice table is the end goal, something we're working towards. You should be able to take a page, measure it, and get a table that literally says, here were your interactions, here's how long it took, here's what part of the stack. Was it input delay? Was it your event handlers running? Was it the amount of time to do request animation frame callbacks? Was it inside rendering style layout? Or was it stuff off the main thread? And you'll get this table and it'll be like, oh, I had, these interactions were sweet. These ones were pretty slow. 80% of the time was spent here. I like drill right in to the answer. And then with low off, you'll get the list of scripts that happen in thing. So hopefully, while responsiveness is hard to tune for, you get a cheat sheet like this, it gets easier. So that's all we got anyway.
But this is not available yet?
It is in Canary. This is not a special build, but it isn't available to the web platform yet. It's making its way through the rounds of review. It's currently either right about to be next released in Origin trial. If anybody runs their own, you're going to have like 3 months to quickly go measure, give feedback, and that'll be very useful to you and to us. So I don't know. You don't have to.
What is the
So this is called long animation frames. That's the keyword, the key name, but it's part of Longcast's API. It's probably just going to be an evolution of Longcast, which is a public web platform feature. Whether it's a different feature because it's enough different or whether it just gets upgraded in place, I think those are all decisions we don't know. For now, it's a matter of, is it useful? Exactly in what form? But yeah.
Is it a lot of data to pick it back?
Well, it depends if you're measuring every interaction. I think less so than the data. Like this table is probably not that much. I would say more, the bigger question for me is crunching the data worth the cost, or is it introducing is it? So I haven't really done too much perf testing of my perf code yet. I am doing quite a bit of crunching here. So how much of that should we offer out of the box? How much data is too much data? These are all things to figure out. These are early experiments.
Any guide on how to implement a good origin trial for this?
Not yet.
Please write one before you open the origin trial. The more data you got, the harder it is to create this kind of experiment.
Have you seen the optimized LCP guidance? So LCP, very popular Web Vital, and there's a table that we created of like, these are the 4 issues that pages have. And if you look across the web, there's no one issue that's the main source, like it's a distribution. You know, the most common one is less than half of sites have this issue, blah, blah, blah. It's like a sliding scale. As an example, time to first byte. If the whole site doesn't even get a single byte down to the browser for a long time, we can't even hope to start fetching LCP, okay? But there's other issues. It might be that the page is on the device, but you haven't actually discovered the image. Like there's just a bunch of stuff, a bunch of scripts, whatever. You haven't discovered the LCP image. Then how long does it take to fetch the image? And then how long does it take to render the image? Any one of those things can be death of LCP. And so what you want to know is, what was your LCP element? What was your overall time? But you want to know those breakdowns. And so like one guidance is just report those 4 numbers. Don't report your LCP to RUM, report those 4 numbers, and then you'll know. I think for INP, you could just take one interaction, your worst interaction, break it down into these 5 pieces. It's starting to look like it's going to be 5 pieces, and just report 5 numbers instead of 1 number. It could be that simple.
Thank you.
Yeah. Thanks for letting us iterate.
If anybody's interested in that origin trial, we can connect you to the person that's writing the API. That's origin trial.
So Chrome has features that are hidden behind flags, and locally you could flip the flag yourself and then you could use it. An origin trial is a way to like put a cryptographic key on your website, and you sign up with a dashboard with Chrome, and together we negotiate, we flip that feature flag for you on your site for your users. And it's a way to do experiments. Remember how a long time ago browsers would have like dash WebKit, dash whatever, and it'd be an experiment, but it'd be everywhere and anyone can use it. But with origin trials, we could say we're going to limit access to this experimental feature to a certain percentage of users, certain percentage of domains, because you have to experiment in order for the web platform to evolve. But now everybody's playing along and we could turn it off. And the other cool thing about experiments is they run for a few versions, but then they expire and you have to like re-up and stuff like that. So it's not like you'll have a bunch of old code that's sticking around forever. So it's like that's the way the web platform does experimentation.
Yeah, we want to be able to change the API so it doesn't get baked in.